All right, so now your calculus skills are getting slightly bigger. So instead of just doing adding and subtracting and powers, we're going to talk about doing products and quotients and adding those things in. Okay, product rule and quotient rule are two different rules, one of which you use when you're multiplying and the other is for dividing. So product rule. When you're taking the derivative of a product, what you do is you recopy the first term and then take the derivative of the second term plus you recopy the second term and take the derivative of the first term. So it's first derivative of second plus second derivative of first. Okay? So looking at a couple of these. So if you're multiplying those two things together, you cannot just hit them separately. That's only for sums and differences, okay? You have to do product rule. So you take the first term and you recopy it, times the derivative of the second term. Derivative of sine of x is cosine of x, plus second term, which is sine of x, times the derivative of the first term, which is going to be 6x. You can put it back here and not simplify it when it's something super simple like 6x. Put it in front, because to write it back here looks weird, okay? And then stop, leave it alone, don't do anything else with it. Just get here and quit, okay? Second one. Okay, so product rule works when you are taking the derivative of two things. Here we have three things. Pick two of them, whichever two you deem the simplest, multiply them together, and then you have two things, and take the derivative of the two things. I'm going to use these two only because I don't want to multiply with that. You can, it doesn't matter, you'll ultimately get the same answer, but I think those two would be easier. So multiplying that out, you're looking at 12x cubed plus 6x squared plus 14x plus 7. And then these two things are dead to us, and you're just working with those two, and you just do product rule. So same thing, you've got first, derivative of second, which is the derivative of this nonsense, which is going to be 36x squared plus 12x plus 14 plus second, which is that stuff, derivative of first, which is derivative of this part, which is going to be 3x squared plus 3 over x squared. Because again, if you're still struggling there, this is going to be negative 3x to the negative first. So then you pull down and subtract and make sure you watch your signs. And then, and this is important, leave it like this, okay? In chapter 3, we do so much simplifying of derivatives, you will get enough practice multiplying everything out. You don't need to do it now. No one needs to see your multiplication skills at the moment, okay? Just leave it like this. Places that you are forbidden to do, well, mostly quotient rule, but in part product rule. Anytime you have a constant times some function, even if it's an ugly function, okay? Oh, let's see, we've got it. You don't do product rule with things like this. You could distribute the 3 if you wanted to. I might. But you don't do product rule when you have constants involved, okay? You take the derivative of this and throw the 3 in front, because it's just a constant. Or, like I said, you can distribute, it doesn't matter. I would probably do it one way some days, a different way the other days. It kind of depends on what I had to do with the problem. And if I felt like multiplying at the time, okay? No product rule though. You do product rule for something that looks like this, and I'll mark you wrong because it's just sloppy. Okay, the same is gonna go for quotient rule, and I'll talk about that. All right, so that's product rule. Now we're gonna talk quotient rule. Product rule, one more small thing. It doesn't matter the order that you write it, whether you start with this term or this term, because there's a plus in the middle. With quotient rule, it matters because there's a minus in the middle, and if you go at it backwards, then all your signs are wrong, and that would be bad. So when you are trying to find the derivative of a constant, it is bottom, derivative of top, minus top, derivative of bottom, over bottom, squared. Way uglier than product rule. Plus, there's a minus in the middle, so you can't mess with the order on the top, okay? When I was in high school, my high school teacher taught me I guess cheesy rhyme to help me remember it. I teach it every year because it helps. Or you can just flat out remember the formula, doesn't matter. So the rhyme that she told me, or us I guess in high school, was it went low, D high, minus, high, D low, over low squared, and away we go. I don't have a lot of tricks for remembering the calculus rules. This is all I got. So you have low D high because it's bottom, which is the low part. D high is why it's the derivative of the top. So then minus high D low, so high, top, D low, derivative of bottom, over low squared, and away we go. And there's a tiny rhyme, and so it helps, and hopefully will let you keep the order on top straight so that you don't mix it up, okay? So we're gonna do a couple of those. 1, 2, 3, 4, 5 of them. And then we're gonna talk about when you are forbidden to do quotient rule, because same thing, it is sloppy. So, it says height, low, D high. So you rewrite the bottom. D high is the derivative of the top. And the derivative of the top part is just 3. Don't put it back here. It's weird. Put it in front. Okay? Minus high, which is the derivative of your top part. High, sorry, again, which is just your top part. D low, which is the derivative of your bottom part. Over low squared. Don't forget that part. I had somebody forget to square the bottom on all of the quotient rule ones. That's it. Again, don't multiply it out. I don't care to see your ability to simplify it. Just leave it alone, okay? Getting it here is good enough. We're going to spend enough time simplifying this stuff eventually that doing it now is not helpful. The only things that I would do, same thing as when you have constants, don't write them in the back, throw them in the front. That takes practically no effort, okay? Please, please, please don't be the weirdo that tries to take fancy and crosses some of that out. That's not math, okay? Leave it. basic one, and then we'll talk about a couple that are slightly messier, and then that will be it. You can write small, hope it fits. So, same deal, you have low d high, so that's bottom derivative of top, which is going to be 10x minus 7 minus high. And something to notice is I looked at my bottom, I realized the derivative was only 6. So I left some space here so I didn't have to try and adjust everything. Like, just smush the 6 there. Over your bottom, squared, and then you sum, and that's it, okay? Please don't simplify it. Stop. Because you'll feel silly if you go to take a quiz, you get here, have this right, simplify it, goof up the simplify it, because that'll mark you wrong, okay? If you're doing work, and you shouldn't be, if you get the word wrong, then it would be wrong at that point. All right, a few other things to keep in mind when you're doing quotient rule. I'm going to write a couple of them down so I can put the book down. Problems like that one have options. Okay, when you have a singular x on the bottom, you can treat it like before we knew that product rule and quotient rule were a thing, and you can put them both over that and deal with them separately. If that is a possibility, it is often easier than trying to do product rule or quotient rule. Okay? You don't have to. You could leave it like that and do quotient rule. I wouldn't. It's a bad idea. It's not technically wrong, though. So this one actually has 3 options. You could do it like this and do quotient rule, which, not awful, but not great. You could rewrite the x as x to the -1/2 and do product rule. I would 1000% not do it that way, because then you've got negative powers all over the place, and if you were to try and mess with it later, if we were further on in the year, this is just yucky. Or you can put them both over the square root of x and just pull a half off of each of the powers. So here you have x over x, which then is really just 3x to the half, minus, this is 5 over the square root of x, and because it's not an integer, I would just write it like this, and then you just have to do power rule twice. I would probably do it like this, or like this, and never this, okay? So looking at it that way, you've got 3/2 x to the -1/2 plus 5/2 x to the -3/2 and the problem's done. Okay, so make sure that you look and see if you can make it easier in the beginning before you mess with it too much. Okay. This is the same type of thing where if you mess with it a little bit in the beginning, it makes it easier in the long run. So what I would do is I would just make common denominators and pull the x down. So then you're looking at 2x minus 3 over x times this, which is really x squared plus x. This is a prettier problem to deal with. It's going to have a prettier derivative. You're not going to have fractional things messing around the problem too much. Is it the end of the world if you do it this way? No. Is it wrong? No. I'll live with it. It's not great though. You want to try and make things as easy for yourself as possible, and making this tiny adjustment in the beginning makes the overall derivative prettier. So if you had to simplify it, which like I said, eventually you will have to, it will be simpler if you make that adjustment now. So then, same thing, you've got low, d high, minus high, d low, over low, squared, and then you leave it. Okay? All right, one more, and then I need to say one thing about quotient rule. Maybe 1.5 things, but we'll be done. Okay. So this is in the same vein as the last one, where if sometimes you do a little bit of work in the beginning, life is easier overall. Wouldn't do product rule between these two things? Because this is just x. Half of your problem then is just recopying this goofy thing. I would distribute the x, treat it as a sum or a difference, and deal with this problem separately. Something to notice is make sure that you keep it f of x until you actually take the derivative. Don't mark it f prime of x in the beginning and then mess with it. Okay, it shouldn't be f prime of x till it's actually the derivative. So we've got two problems here. This is just 2. This requires you to do quotient rule. There is a minus in front, so do minus, just put parentheses, so then you don't have to worry about distributing it or messing with it or what it's supposed to look like. Just throw some parentheses in, okay? So then same thing, you got bottom, derivative of top, minus top, derivative of bottom, which is 1. Don't write that down. Over the bottom, squared, and you're done, okay? So, one place where you are forbidden to do quotient rule, and if you do quotient rule with it, I will dock you because it is sloppy. Really, 2 places. So if you have some function over a number, you are forbidden to do quotient rule, okay? Number 1, half the quotient rule would be 0. But really, it's just each of these top terms over that bottom number, or say you had 2x cubed plus 5x minus 7 over 4. You either put them each over 4 individually, or you think about it as being 1/4 times the function, and then just take the derivative of the function and multiply it by a 4th, or put it over 4. Really, you're just taking the derivative of this part and leaving it over 4. Okay, that's how that works. You do quotient rule with something like this, it's wrong because you're just being sloppy. Okay. Similarly, if you have a polynomial like this that doesn't have any trig involved over just an x, x squared, x cubed, whatever, x to some power, and you do quotient rule for something like that, that's also sloppy, and I'll mark you wrong because you're just not looking at the problem. Squared, it doesn't matter. You would put them each over the x squared and deal with the terms individually, okay? If it was something like this, or the flipped over version of this, that you can simplify. You just have to do quotient rule with those types of things. Okay, but basic polynomials over x's, you need to put them each over the x squared individually like we did before and deal with it as a sum or difference problem. Same thing for this. And that's it.